Dear students, I am Sudipayan Bhattacharyya here. In this video, I have put my effort to make you understand about relations and functions. This class is organized according to the syllabus of class 9 and class 10, but anyone interested can attend this class, but make sure that you have a very good idea on theory of sets. So let's start. Topics that will be discussed in this class are Cartesian product, relation, domain of a relation, range of a relation, inverse relation. Suppose Abul, Babul and Kabul are three football players. Let us denote them by A, B and C respectively. That means A, small a represents Abul, small b represents Babul and small c represents Kabul. Now if you have three jerseys with numbers 1, 2 and 3, think how many possible ways to distribute the jerseys among A, B and C. What are the ways? Here is a picture showing Abul, Babul and Kabul. The red person is Abul, the green person is Babul and the blue person is Kabul. 9 pairs are possible. How? Abul can be related with jersey 1, Abul can get jersey 2, Abul can get jersey 3, and also Babul can just get jersey 1, Babul can get the jersey 2, Babul can get the jersey 3. Kabul can get the jersey number 1, Kabul can get the jersey number 2, and Kabul can get the jersey number 3. So these are the 9 cases or 9 pairs that are the possible ways to distribute the jerseys among Abul, Kabul and Babul. If you look at the pairs I have written here, you can see that I put two characters within first bracket. The first position is taken by the players and the second position is taken by the jerseys. These type of pairs are called ordered pairs. Now we are going to define Cartesian product mathematically. Suppose A and B are two sets, then the Cartesian product of A and B is the set that contains every possible pair of elements where first elements of the pairs come from A and second elements of the pairs come from B. The Cartesian product of A and B is denoted by A cross B. A cross B is equal to xy such that x belongs to A and y belongs to B. That is, xy is a pair. It is called an ordered pair in which the first element x comes from the first set A and second element y comes from the second set B. For example, if A is equal to A, B and B is equal to 1, 2, 3, then we can write A cross B like this. The first pair will be A, 1, second pair will be A, 2, third pair will be A, 3, and then B, 1, then B, 2, and lastly B, 3. Some important features that are to remember about Cartesian product. Every element of a Cartesian product is a pair. The pairs are called ordered pairs. In an ordered pair, first element comes from first set and second element comes from the second set. Like for A cross B, You may take A1, but you cannot take 1A for the previous example. A1 and 1A are not the same thing. Every ordered pair is element of some Cartesian product. If an ordered pair A, B is equal to another ordered pair x, y, then A is equal to x and y is equal to b. Now I have some works for you. Your time limit is 3 minutes. Please pause the video and copy these problems, solve the problems, then resume the video again. Relation. Now we are going to talk about relation. First, we will go back to the first example of the players and the jerseys. Do all of the players get all of the numbers for their jerseys? Traditionally, each of the players can get only one number for his or her jersey. In practical, the distribution of jersey numbers depends on some conditions or situations or rules, like tradition, rule of the club, choice of the players, lottery, vote of the fans, etc. But in all of above cases, after the distribution, whichever jersey goes to whichever player, it just makes a relation. By a jersey number, we can recall the name of a player. So what relation is? Look, after distribution of the jerseys 1, 2 and 3 among Abul, Babul and Kabul, the following relations may be possible, like Abul got the jersey number 1, Babul got the jersey number 2 and Kabul got the jersey number 3, that is A1, B2 and C3. Let's put the pairs in a set. Now the jersey distribution may be like this one. Abul got the jersey number 2, Babul got the jersey number 1 and Kabul got no jersey. So it is also a kind of distribution. Let's put A2 and B1 in a set. Now another distribution may be like this. Kabul got jersey number 2 and Abul and Babul got no jersey. That is only one distribution, C2. Let's put it in a set. You can build up many other possible ways to distribute the jerseys. But look at these three sets. The sets above is representing a specific relation between players and jerseys. So, what can be the definition of relation? A relation from a set A to a set B is some non-empty subsets of A cross B. We can say that if R is a non-empty subset of A cross B, then R is a relation from A to B. In other words, a relation is simply a set of one or more ordered pairs. Because every ordered pair is a representative of a specific relation, such as the pair 3, 4 shows that 3 is somehow related with 4. For example, Here A is a set of pairs AP, BQ and CR. It is a relation. Work. For this work you will get 2 minutes. Please pause the video and solve it by 2 minutes and resume the video again. Now I am going to explain the relation in more detail. Look at the diagram. Suppose A is a set containing small a, small b and small c, and B is another set containing 1, 2 and 3. Now this diagram is representing a relation from A to B such that A is related to 3, B is related to 1, C is related to 2. Let us name this relation F. Using the set, we can express this relation as follows. F is equal to A3, B1, C2. Now we are going to learn some terminologies and notes for relation. You must remember, in a relation, the first element of the ordered pairs are called pre-images. The second elements of the ordered pairs are called images. Set of all pre-images is called the domain. Set of all images is called the range. Every image is somehow related to its pre-image with some general or discrete rule. For example, we can say from the diagram, let us name this relation S. Here S is equal to A3, B2, C2. The pre-images of this relation are A, B and C. Hence, the domain of S is A, B, C, because we know that set of all pre-images is called domain. And look at the images. The images are 3, 2 and 2. Therefore, the range of this set, therefore, the range of the relation is 2, 3. Note that domain of relation S can be written as dom S in short. Range of a relation S can be written as ranges in short. For example, let's take S, where S is equal to 1, 0, 2, 1, 3, 2 and 4, 3. Find the domain and the range of S. Now we are going to find the domain and range of this relation. We will write that domain of S, that is dom S, is equal to the set of first elements, that is the set of pre-images. Set of pre-images is 1, 2, 3, 4, and ranges. Range, what is range? Range is the set of second elements or set of images. Set of images. Here images are 0, 1, 2 and 3. The last topic of our class today is inverse relation. So, what is inverse relation? If S is a relation, then inverse relation of S is denoted by S superscripted -1, where S superscripted -1 is equal to BA such that AB belongs to S. What does it mean? It means that taking all the opposite ordered pairs, you can build up an inverse relation. For example, S is equal to 1A, 2B, 3A, 4B is a relation, then S inverse is equal to A1, B2, A3 and B4. Look carefully. All the pairs contained by S inverse are opposite to the ordered pairs contained in S. Let's see the diagram. The diagram representing S, where images are from B and pre-images are from A. That is, the relation goes from A to B. But look at the inverse of S. The images comes from A and pre-images comes from B. That is, the relation goes towards the direction from B to A. So you can say that if we replace all the images by pre-images and all the pre-images by images, then we will get inverse relation. Now it's time to solve a problem. Here is a problem for you. Please pause the video and copy this problem. Solve it. I will give a solution of this problem in my next video. Till then, try it yourself. Special thanks to you for your active participation. Stay home and stay safe.